now?
Yes, we can see.
Okay. So for today's, I'm going to talk about, for example, when we learn about all this Lewis structure, we may wondering what do it do to our lives? And it just, we're doing general chemistry. However, today I'm going to bring up a topic, which is free radicals and its impacts on our human body. So first of all, what is a free radicals? So free radicals is an uncharged molecules having an unpaired electrons in the outer orbitals. So as you can tell right here, we have a very stable molecules, and when it loses an electron, it becomes very unstable, and we call it free radicals. So when it loses an electron, it's hungry to, steal an electron from other from the neighbor atoms, and making these the neighbor atoms becoming a unstable molecule, and then this molecule are going to steal an electron from the as well as the neighbor atom. So it's gonna become like a chain reaction. So free radicals are highly reactive and short-lived. So in our human body, we're talk most likely about oxygen free radicals. So where do free radicals come from? So there are two generation. First of all is physiologic generation, and the second is pathologic generation. So for physiologic generation, it occurs in the oxidative phosphorylation. As if you don't know, oxidative phosphorylation is a process in our human body to generate ATP. So what it do is the mitochondria creates electron, and it's going to pass through all these channels until oxygen is going to accept those electrons and become water. So as you can tell right here, we have an oxygen molecule, and it's going to accept one electron, become a superoxide, except another electron is going to become hydrogen peroxide, and another one is going to become hydroxyl free radicals until it's going to become water. So water, when oxygen become water, it is marked as a complete reduction. And whenever we stop in the between, we're gonna have all these free radicals flowing around. And the second thing is pathologic generations. For example, when we do cancer therapy, or as known as ionization radiation, hydroxyl free radicals is formed. And among these three, hydroxyl free radicals is the most dangerous. In our free radicals also being released by a natural process in our human body when we fight against outer invasive, and it's called the white blood cell oxidative burst. It's gonna generate free radicals and to kill a pathogen in our body. So, and as far as we doing, for example, when we drink some drugs such as Tylenol, is going to end up in our lungs, and it's going to release a huge amount of free radicals, which is going to cause damage to the liver. And as far as you know, in our blood is being composed of hemoglobin, and it's iron is the very important part of that. And when iron is being passed in our bloodstream, it's gonna as iron 2 plus is going to accept all these free radicals and form iron 3 plus and those two free radicals. And this process is going to be reversed again, and this happens simultaneously. So free radicals going to cause a huge damage to our cellular function by keep stealing electrons from from different atoms in our body, and it can cause damaged cells via membrane lipid peroxidation. So as far as you know, right here, our cells being composed of phospholipid bilayers, and even free radicals gonna attach and steal electrons from one of these. This one is going to become a free radicals, and this keeps stealing an electron from a neighbor cell, and neighbor cell is going to cause damage to this entire membrane. The second thing is going to cause DNA breakage, which can cause cancer. So as far as you know, DNA is like is going to create a lot of proteins, which gonna, create all parts of our human body. If there's a change in our DNA, it can cause a lot of like protein modification, and there's a lot of autoimmune disease related to that, such as Alzheimer's, Parkinson's, and myocardial infarctions. So let me show you guys kind of like a demonstration. So we have right here. So this is a free radicals. It's gonna try to steal an electrons from others atoms, and this is our DNA sequence. Is gonna trying to steal electrons. Is gonna cause a huge damage to our DNA, and it could cause damage to the entire cell by causing damage to DNA, because um, is gonna DNA produce proteins. So in this particular picture right here is called oxidative stress reaction, where one damaged cells is gonna, because these are it has many free radicals in it. It's trying to like steal electrons from their neighbor cells as well. It's called a huge damage to our body. Let's get back to the slides. And also, free radicals gonna induce cellular apoptosis, which is cell death, and to prevent further injury in the body. So how do we like eliminate all these processes? So first of all, spontaneous decay. So as far as I've talked before, free radicals is very short-lived, and it can, eventually disappear shortly. And one other way we could eliminate free radicals is through antioxidants. So, and we can add that by, adding vitamin A, C, E. Antioxidants are like a molecules which has like, it says electron for the free radicals to take without damaging with that. So the antioxidants won't become a free radicals. Metalloproteins such as transferrin and ceruloplasmin is copper. So as I explained right here, we have iron is being passed through in our body with, and if it doesn't have any proteins to carry it, it would try to bind to a lot of free radicals, and it would generate even more free radicals. So we could want to talk about scavenging enzymes, and these free radicals in our body is gonna be reacts with all these different enzymes to eliminate the generation of free radicals itself as well. And those are my presentation. Thank you a lot.